Hello class, this is Econ 510 Managerial Economics class. Today is March 22nd, Tuesday. The class will discuss the various forms of monopoly firms. So here is the order of today's video clip we are going to cover. 1. Introduction to monopoly theory. 2. Pure monopoly. 3. Introduction to monopoly theory with numbers. 4. Introduction to monopoly theory with calculus. 5. Natural monopoly and governmental regulation. 6. Profit maximizing and revenue maximizing monopoly. 7. Social cost of a monopoly. 8. Total revenue, marginal revenue of monopoly. 9. Patents and monopoly power. Here is the first video clip.
I'm also going to show you how to calculate the profit, revenue, and cost for a monopoly. And finally, I'm going to show you what happens to consumer surplus and price and quantity when you compare a monopoly with perfect competition. Simply put, the demand curve for a monopoly looks a lot like the market demand curve because they are the market. And they control the market and they set prices and quantities. So at this price and this quantity, I can calculate revenue for the monopoly, and that's that point right there. So I take total revenue is equal to price times quantity, or P times Q. The first thing I'm going to do is build the total revenue curve. So I'll bring down the quantity straight down, and on the vertical axis I'll plot total revenue. So at this particular level of quantity, at this level of quantity, that is my total revenue. Right there. I'm going to do this at several different price points and quantity points. At high prices, the monopoly doesn't sell very much and they don't get a lot of revenue. At a more moderate price, they sell quite a bit more, and this is their revenue level right there. And at lower prices, they sell more, but they actually make a little bit less money, a little less revenue, and that would be the point right there. So this is what the total revenue curve looks like. Kind of goes up and then back down. Average revenue is worth mentioning as well. And the way I calculate average revenue for a monopoly is I take total revenue divided by quantity, that's average revenue, which is price times quantity divided by quantity. So those two quantities cancel out. So it turns out that average revenue is always equal to price. So whatever my price is, that's my average revenue, regardless where I'm at on the demand curve. It turns out the demand curve and the average revenue curve are exactly the same, because demand in this case is equal to average revenue. Marginal revenue is always a little tricky. I'm going to do that one now. And marginal revenue is the change in total revenue due to a change in quantity. And change, I'll use a little delta sign, the Greek letter for delta. My first level of quantity is right there, and my associated total revenue is right there, and I'll plot that across. So I have TR1. If the monopoly increases quantity to level Q2, right there, total revenues rise. So right there, total revenue 2. What I'm actually going to show you is the slope. If you remember, the slope is rise over the run right there. So I'm going to take the rise divided by the run, which is the slope. That's the same thing as rate of change, by the way. So I take total revenue 2 for my second quantity minus my first total revenue 1, divided by the second level of quantity, or Q2, minus Q1, the first level of quantity. And this is equal to a change in total revenue divided by a change in quantity. Again, change is that little delta sign, Greek sign for delta. And this is equal to marginal revenue. It turns out that marginal revenue is just the slope of the total revenue curve, and that's that green line there. And the slope's not constant, and it changes all the way through the total revenue curve. This point's a very important point because there the slope is 0, and so is marginal revenue. It's 0 at that point. And if I take the point up there and I draw my line straight down like that, that's my marginal revenue curve. To the right of the dotted line, marginal revenue is negative, the slope is negative, as you can see. So by definition, marginal revenue is equal to change in total revenue divided by the change in quantity. There is nothing special about the marginal cost and the average total cost curves for monopoly. It's calculated exactly the same as for perfect competition, so I'll draw those in. Marginal cost and the average total cost. The marginal cost curve and the marginal revenue cross is the level of quantity produced. And if I take it and I draw straight up, that gives me the price for the monopoly as well. So total revenue is equal to price times quantity. Again, if I go from the quantity up to the average total cost curve and across, this gives me my average total cost, which is the area of the red triangle. It's average total cost times quantity. That's the area. And if I take total revenue minus total cost, that's the profit, which is that black area there, the area of that black rectangle, I should say. The height is P minus average total cost, or price minus average total cost. The base is quantity again. So profit is equal to quantity times price minus average total cost. And again, profit is total revenue minus total cost. So in perfect competition, the market will produce a point right there and produce a quantity which is much higher than a monopoly would produce. And their prices would be less as well. In other words, monopolies charge more and produce less. Under competition, that's consumer surplus, but under monopoly, consumer surplus shrinks. The consumer is worse off.
In today's video lesson, we're going to introduce a new market structure. We'll be talking about perfect monopoly or pure monopoly. A purely monopolistic market structure exists when there is a single seller. In other words, the market for a good is dominated by one firm. Finally, the demand for the good in the entire market is the demand for the individual firm's output. These characteristics of pure monopoly will be very important when we begin our analysis of this market structure today. So, before we can illustrate the amount of output that a monopolist will wish to produce and show the area of economic profits a monopolist might enjoy, we first must derive a demand curve for a monopolist's products. So in our graph on the left, we're going to be examining the market for airplanes. Now we're making some assumptions here. We're assuming that the airplane market is a pure monopoly. In reality, of course, there are several companies that manufacture airplanes, but we are hypothetically referring to a purely monopolistic monopoly market here, in which there is only one firm supplying airplanes to the entire industry, and they are considering producing up to 6 airplanes and charging prices ranging from $0 to $60 million, as we can see on our vertical axis here. So let's move over to our demand schedule on the right. A demand schedule shows the relationship between the price of a good and the quantity demanded by consumers for that good. We've got a range of quantities here ranging from 6 to 1 airplane. Let's now think about the relationship that will exist between the quantity demanded and the price of airplanes that the monopolist attempts to charge. So earlier in the course we learned the law of demand, which stated that there is an inverse relationship between the price of a good and the quantity demanded. A monopolist can expect to sell more airplanes at lower prices, while at higher prices sell fewer airplanes. So we're going to assume that there is an inverse relationship between the price of airplanes in the market, dominated by one monopolistic firm, and the quantity demanded. So at higher prices, let's say at $60 million, the monopolist should only expect to sell 1 airplane. However, by lowering its price to $50 million, the quantity demanded among airlines, the buyers of airplanes, will increase to 2. And as the price of airplanes continues to fall, the quantity demanded will continue to rise. At $10 million, this monopolist could expect to sell 6 airplanes. Now this is all very hypothetical, but it's not unrealistic to assume that as the price of airplanes falls, more airplanes will be demanded by the consumers of airplanes. So we can plot the monopolist's demand curve by plotting the points from the demand schedule in the graph on the left. So at $60 million, this firm and the industry as a whole can expect to sell only 1 airplane. But as the price of airplanes falls to 50, the quantity demanded will increase to 2 airplanes, and so on. We clearly have a linear relationship here between the price and the quantity demanded for airplanes. At $10 million, 6 airplanes will be demanded. If we connect the dots, what we'll have is the monopolist's demand curve, and in fact, the industry demand curve for airplanes, since the monopolist is the only producer of airplanes. We're going to label this curve demand for airplanes. Now, the first thing we should notice in a monopolistic market compared to a perfectly competitive market, which we have already studied, the demand for an individual firm's output is downward sloping. That's an important characteristic of a monopolistic market. The individual firm's demand is downward sloping. This means that the firm has some price making power. By which I mean, if the firm wished to raise its price, all it would have to do is reduce its output, and it could charge a higher price for its product. However, if the firm wished to lower its price, it could do so by increasing its output, since in order to sell the additional output, it would have to lower its price. So we can say that purely monopolistic firms are price makers, in contrast to perfect competition, in which individual firms face a horizontal or perfectly elastic demand curve, meaning that pure competitors are price takers. They cannot control the price of their own output, since they must accept the price determined in the market. But since a monopolist is the market, in other words, there are no competitors, the monopolist determines the price that it sells its output for. As the price changes, the quantity demanded will change based on the market demand for its product. So the next question we want to ask is, how will a monopolist know what the profit maximizing quantity to produce at is? Before we can determine where the monopolist should produce, we should review the profit maximization rule learned earlier in the course. In order to maximize profits, a firm should produce where its marginal cost equals the marginal revenue for its product. The profit maximization rule says produce where MR equals MC. Now looking at our graph, we can see that there is no marginal revenue curve, nor is there a marginal cost curve. In our previous market structure, perfect competition, we saw that demand corresponded with the marginal revenue of individual firms, since the firm can sell as much output as it wished at the given equilibrium price. Therefore, the equilibrium price was the marginal revenue. However, in pure monopoly, demand is not equal to marginal revenue. Because of the very nature of this market structure, marginal revenue will always be less than the price the firm can sell its product for. To illustrate why, let's look back at our table here on the right. We can find the total revenue at any level of output by multiplying the price times the quantity at that level of output. And once we know total revenue, we can find the marginal revenue, which is simply the change in total revenue over the change in quantity. So let's start by finding total revenue at each of the levels of output ranging from 1 airplane to 6 airplanes. Total revenue is just price times quantity. So the total revenue of the first airplane at $60 million is $60 million. It's the price that the firm sold the airplane for. At the second airplane, the total revenue increases to $100 million, $50 million times the 2 airplanes sold. I'll go ahead and fill in the rest of this column now. Notice that as the firm increased its output from 1 to 6 airplanes, total revenue increased at first from $60 million to $120 million, but beyond the 4th airplane, total revenue began to decrease back down to $60 million. This firm would clearly not wish to produce 6 airplanes, since its total revenue of producing 6 airplanes would be less than if it produced only 3 or 4 or even 5 airplanes. Now, marginal revenue is what we're really interested in here, because knowing the marginal revenue will allow us to determine the profit maximizing quantity that the firm will wish to produce at. Marginal revenue is just the change in total revenue divided by the change in quantity. In this case, the change in quantity is always 1 airplane, so marginal revenue will just be the change in the total revenue. As we went from 0 to 1 airplanes, the marginal revenue equaled the price of the first airplane, $60 million. But then marginal revenue began to decrease more rapidly than the price decreases. The marginal revenue of the 3rd plane is only $20 million, and for the 4th plane, there is no change in total revenue, so marginal revenue is 0. Then marginal revenue becomes negative, and ultimately marginal revenue will be negative $40 million for the last airplane. By increasing its output from 5 to 6 airplanes, this monopolistic seller's total revenue fell by $40 million. Not a good idea to increase output to 6 airplanes. If we plot the points from this marginal revenue table, we will have the marginal revenue curve. The first unit of output, marginal revenue, equals the price, but as output increases, marginal revenue falls more rapidly than price. At the 4th unit of output, the marginal revenue is equal to 0, and then marginal revenue becomes negative beyond that. If we connect these points from our marginal revenue table, we will have our marginal revenue curve, which, as you can see, lies below the demand curve. There's our marginal revenue curve for this airplane manufacturer. Now we have half of what we need in order to determine the profit maximizing quantity. All we must do now is add some cost curves to this graph. Now a firm in pure monopoly will face the same sorts of costs that a firm in perfect competition will. Marginal cost, average total cost, and average variable cost. For our sake, we're only going to bother drawing the marginal cost and the average total cost curve here, because that's all we need to determine whether or not a monopolist will be earning economic profits or losses or breaking even. Notice the relationship between the marginal and average total cost curve. Just like in perfect competition, marginal cost will intersect ATC at its lowest point. Now that we have our marginal cost and our marginal revenue curve, we can determine the profit maximizing level of output for the monopolist. In our graph, we see that marginal cost and marginal revenue intersect just around 3 airplanes. If we draw our dotted line up, we can see that at an output of 3, the price that the firm can sell for is around $40 million. So the equilibrium price in this market will be around $40 million, and the firm's average total cost lies below the price at around $30 million. Our monopolist in this airplane industry will want to produce 3 airplanes and sell them at a price of $40 million each. At this quantity and price combination, our monopolist is earning economic profits equal to the yellow rectangle. In our study of perfect competition, we recognized that anytime economic profits exist, firms will enter the market, the price of the good will fall, and those economic profits will be eliminated in the long run, as the firms are forced to produce at their minimum average total cost in order to remain competitive in the market. Will this happen in our monopolistic market? We need to go back to our characteristics of pure monopoly in order to determine whether or not this firm's profits will be eliminated due to the entrance of new firms. In fact, one of the most important characteristics of pure monopoly is that there are high barriers to entry. This means that economic profits can be earned in the long run. It is very difficult for new firms to enter this market due to the barriers to entry. In our airplane market, one of the more significant barriers to entry is probably economies of scale. An airplane manufacturer in the real world, such as Boeing or Airbus, has achieved many economies of scale that new potential competitors will not be able to achieve at a low cost. Therefore, the profits earned by real airplane manufacturers or other firms in monopolistic or nearly monopolistic markets are likely to persist in the long run as long as demand for their product remains stable or high. If demand for airplanes falls, then yes, these profits might be reduced or even eliminated. However, assuming demand for airplanes remains constant, monopolists can expect to earn economic profits in the long run. So these profits that we have drawn here will persist in the long run as long as the firm's costs do not increase or the demand for the firm's product does not decrease. But one thing we should notice about pure monopoly is that the quantity produced by a monopolistic firm, and therefore in a monopolistic market, is less than that which would be produced under perfect competition. Under perfect competition, the price of the good will always equal the marginal cost in the long run, therefore a greater quantity will be produced. We're going to explore later the reason that purely monopolistic firms are inefficient, their price-making power, and the fact that the marginal revenue lies below the demand and the price of the good indicates that in the long run, monopolistic firms will produce less output than would be produced in a similar competitive market. In addition, the firms are more likely to earn economic profits due to the high barriers to entry, such as economies of scale, enjoyed by firms in these markets. So this lesson was meant to introduce the concept of demand and marginal revenue for a purely monopolistic firm. What we need to see is that the marginal revenue lies below the demand curve, yet the demand curve is downward sloping due to the fact that the monopolistic firm is the only seller in this market. Therefore, the demand as seen by the firm is the market demand, which, according to the law of demand, should always show an inverse relationship between the price of the product and the quantity that consumers are willing to.
What do you remember about perfect competition? I mean, how would you recognize a perfectly competitive industry if you ran across one? In perfect competition, 1, there are a large number of sellers. There are a large number of buyers too, but we won't be worrying about that just now. No individual is large enough to affect the market. 2, the product is homogeneous or identical or non-differentiated. For example, milk. When you go to buy 2% milk at the supermarket, what brand do you buy? If you're like me, you buy whatever's on sale. I have no brand loyalty whatsoever because milk is milk. 3, there's perfect information. It's actually not enough for products to be identical. Everyone has to know that the products are identical. Otherwise, we could be fooled by things like pretty packaging or celebrity endorsements. In a perfectly competitive industry, firm versus firm advertising is useless. All you'd be doing is driving up your own costs, and then customers would just buy from a cheaper competitor. However, you may see industry-wide advertising like the Got Milk campaign, pork, the other white meat, or beef, it's what's for dinner. These kind of campaigns raise demand for each firm's product across the industry. 4. Easy entry and exit. Because firms can enter and exit the industry at will, long-term profits will be effective, but we'll get to that in just a bit. For the individual firm owner, the combined effect of these characteristics is that he or she has no power to control price and will earn zero economic profit in the long run. Let me ask you this. If the individual firm cannot set the price, then where does the price come from? Think back to our market activity earlier in the semester. In a market with lots of buyers and sellers, the price is determined collectively by the market supply and market demand. This, then, is the prevailing price for each firm. What happens if the firm doesn't like this price? If it tries to charge more than P star, all of the customers will go someplace else, so the firm would be forced back down to P star. If it tries to charge less than P star, then all customers in the industry will come to this firm. Sounds good, right? Wrong. This firm cannot accommodate the entire industry demand. Costs would skyrocket. The firm would be forced back up to P star to get rid of some of the customers. All of this means that the firm is a price taker, forced to accept P star, the market-determined equilibrium price. Note that this also means, because the firm charges P star regardless of the quantity demanded, that P star represents the firm's demand as well. Remember that perfectly elastic demand curve from earlier this semester, where consumers are so hypersensitive to price that price is all that matters? Well, that's this market structure. Okay, so you're a producer in a perfectly competitive market, and you have no control over the price that you can charge. Is there anything you do have control over that you can make decisions about? A perfectly competitive firm may not be able to choose its price, but it can choose how much output to produce. The firm owner will choose the level of output that will maximize his or her profits. See episode 26b to see why. Marginal revenue equals marginal cost will always be the profit maximizing role. So, you're a firm owner in a perfectly competitive industry. You can't choose the price that you charge, but you can select the amount of output that you produce. In order to maximize profit, you will always choose the level of output where marginal revenue equals marginal cost. Take a look at the perfectly competitive firm and see where this occurs. I need to choose output such that marginal revenue equals marginal cost, but right now I don't see marginal revenue or marginal cost. Let's start with marginal revenue. Marginal revenue is the additional revenue that you earn when you sell an additional unit of output. For a perfectly competitive firm, since all units are sold for the same price, each unit sold always adds the same amount of revenue, P star. For example, if price is $5, then the total revenue for 0 units is $0, for 1 unit is $5, for 2 units is $10, and so on. Selling 1 more unit generates $5 additional of revenue each time. Therefore, marginal revenue is equal to the equilibrium price. Note that this is only true for perfect competition. What about marginal cost? Well, marginal cost is actually pretty easy. We constructed the cost curves, marginal cost included, before knowing anything about market structures. Those cost curves are the same regardless of the structure we're operating in. This means that the marginal cost for the perfectly competitive firm is just marginal cost. Remember that J-shaped Nike swoosh thing? And now, all we need to do is select the level of output where marginal revenue equals marginal cost. Now, because there are no average cost curves in this diagram yet, I can't actually show you how large or small the profits are, only that Q star will be the best level of output for this particular producer based on the profit maximizing rule. Let's look at just one example of how to find profit using this model, then we'll do more cases in class. What if my perfectly competitive producer is operating in an industry where price is greater than the cost per unit? I can already tell that this producer will be making profits since there's more coming in for each unit than there is being paid out in cost, but let's see what it looks like. Notice that I've positioned the average cost curves below the price line. Where is MR equals MC? This gives me Q star. At Q star, what is the total revenue coming in? Revenue is the price I can charge times the number of units that I sell. In this case, the green area. At Q star, what's the total cost of producing this output? It's the cost per unit, ATC, times the number of units that I sell, in this case, the red area. The amount of revenue, in green, that doesn't get chewed up by the costs, in red, is profit. In this case, I've indicated profit by the blue area. In the short run, this producer earns positive profits. Why do I say in the short run? Because those short run profits attract the sharks. Other outside firms see the profits and enter the industry to set up shop. This causes industry supply to increase, driving the price downward. In the end, the entry only stops when there are no more profits to attract the sharks, until price is equal to average total cost and the firms just break even. In the long run, a perfectly competitive firm's profits are always equal to zero. Next time, monopoly.
This is the second video in a 4-video playlist, and the other videos run from introduction to the calculus proof. In this video, though, I'm going to do monopoly theory, or introduce you to monopoly theory using some numbers. Here's what the final product looks like, and I'm also going to graph the numbers and show you where marginal cost equals marginal revenue. In this case, the monopoly is going to produce a quantity of 7, and that's where marginal cost equals marginal revenue. I'm going to tell you the answer, but then I'm going to go through all the calculations also. First, I'll calculate total revenue, then profit, average revenue, average cost, marginal revenue, and marginal cost. Quantity is given, price is given, and total cost is given. So the very first thing I'm going to calculate is total revenue. Total revenue is quantity times price, and this is equal to total revenue. So I have 0 times 10, a price of 10 is equal to total revenue of 0. You don't sell anything, you don't make any revenue. I have a quantity of 1 times a price of 10 is equals to a revenue of 10. I'll just do 1 or 2 more. So I have 2 times 980, which is equal to 1960, total revenue. So I'm taking the quantity column times the price column for total revenue. And now I'll just fill in the rest of the values. Profit is equal to profit. Turns out to be total revenue minus total cost is equal to profit. If I have total revenue is 0 minus total cost is 0, I have 0 profit. Don't make anything, don't sell it, don't make no money. Total revenue is 10, total cost is 8, profit is 2. Total revenue is 1960, total cost 1525, total profit 4.35. Now let's fill in the rest of the values. I think you got that. Now I'm going to calculate average revenue. Total revenue divided by quantity is equal to average revenue. I'm going to calculate average revenue for the second row there, the highlighted row. So I have revenue of 10 divided by a quantity of 1 is equal to average revenue of 10. Now I'm going to calculate average revenue for a quantity of 2. So I have 1960 divided by a quantity of 2, and this is equal to 9.80. Now let's fill the rest in. Now I'm going to calculate average cost. total cost divided by quantity is equal to average cost. So the first value, I take 8 divided by 1, gives me an average cost of 8. Now I have a value of 15.25. A total cost of that divided by 2 is equal to 7.63. I'll just fill in the rest of the values now. Now I'm going to calculate marginal revenue, marginal cost. Those calculations are slightly different than what you've probably seen before. So I take marginal revenue is equal to the change in total revenue due to some change in quantity. When quantity goes from 0 to 1, total revenue goes from 0 to 10. Therefore, I take 10 minus 0 divided by 1 minus 0. This equals, of course, 10 divided by 1. So the marginal revenue is equal to 10. If quantity increases from 1 to 2, then total revenue goes up from 10 to 1960. And the way we make this calculation is we take 1960 minus 10 divided by 2 minus 1. This is equal to 9.60 divided by 1. So marginal revenue is 9.60. In my case, in my example, quantity always increases by 1. So it seems almost silly to do the change in quantity, but you probably have examples in your classes where quantity does not increase by 1, so you want to get in the habit of making that calculation. Now I will fill in the remaining values. Marginal cost is very similar to marginal revenue, and it equals the change in total cost divided by the change in quantity. When I go from 0 to 1 quantity, total cost goes up from 0 to 8. So I take 8 minus 0 divided by 1 minus 0. This is equal to 8 divided by 1. And of course, this is equal to a marginal cost of 8. If quantity goes from 1 to 2 units, cost goes from 8 to 15.25. So I go 15.25 minus 8 divided by 2 minus 1. And this is equal to 7.25 divided by 1, which gives me a marginal cost of 7.25. I'll just fill in the rest of the values there. And this was what the completed table looks like. It's not hard calculations, just tedious. Now I'm going to graph marginal cost, marginal revenue, average revenue. And this is the average revenue, or the demand curve. Marginal revenue looks like that. And finally, marginal cost. As planned, they intersect, marginal cost and marginal revenue intersect at 7. If I go straight up, that gives me the price of 8.80, which is in the table as well. So these are my equilibrium values. Marginal cost 750, marginal revenue 750. And if you notice, profits 10.75 at 7 units. It's 10.65 at 6, a little lower, and 10.35 at 8. So just right, maximize profit at 7 units. One last set of curves. If you notice, I'll put in the total revenue and total cost curves. Obviously, I drew them in. And now the marginal cost, average revenue, and marginal revenue. If I go straight up, that distance between those two curves, total cost and total revenue, that's where profit is maximized. If you haven't done so already, I would encourage you to watch the introduction video on monopoly theory. It should help out. And also even give the calculus a go.
Remember profit, total revenue minus total cost? How do I figure out how much output yields the maximum amount of profit? Well, I remember total costs, and while I don't remember seeing total revenue before, I think we can figure it out. It's just price times quantity, right? And since price is always P star, let me say for the moment that P star is $5. If that's true, then for output equals 0, revenues equal 0. But if output equals 1, revenue is $5. And output of 2, revenue is $10, and so on. That means that for perfect competition, total revenue is just a straight line, increasing at each unit by the amount of the price. But what about profit? Remember that profit is the combined effect of total revenue and total cost. This still doesn't show profit directly, but it does give us the information needed to figure out what profit's going to look like. For example, at output levels Q1 and Q2, what's the profit? At both of these output levels, the total revenue is exactly equal to the total cost, so the profit's 0. What about output levels from 0 up to Q1? Because total cost is higher than total revenue at these levels of output, there are losses in this range. Do losses occur anywhere else? Look to the far right, beyond output level Q2. Again, total cost is greater than total revenue, so there are losses. This leaves us with output levels from Q1 to Q2. In this range, total revenue exceeds total cost, so profits are earned. Now that we have an idea what profit looks like at different levels of output, what level of output would you pick if this were your business? As a profit maximizer, you would want to pick the level that yields the highest profit. In this diagram, that would be output level Q star. How will I know that I have achieved this optimal level of output? Remember, at the maximum point, slope, or rise over run, or in this case, change in profit over change in quantity, has to be equal to 0. If I break this down a little, I'll get some terms that I recognize. For maximum profit, the firm owner chooses the level of output at which marginal revenue equals marginal cost. Marginal revenue equals marginal cost is always the profit maximizing rule. Think about it this way. What if marginal revenue is not equal to marginal cost? For example, what if marginal revenue is greater than marginal cost? This means that more is being added to revenue than to cost, so profits are still rising. You would want to increase your output until marginal revenue equals marginal cost. And what if marginal revenue is less than marginal cost? In this case, more is being added to cost than to revenue, so profits are falling. Notice this does not necessarily mean that profits are negative, just that profits have gone past the maximum and are now decreasing. In this case, you would want to cut back on your output until marginal revenue equals marginal cost. In the end, marginal revenue equals marginal cost is always the profit maximizing rule, no matter what the market structure. Next class, we'll do some problems using this profit maximizing rule.
I'm going to show you visually what happens as we do the calculus. I'll show you that along the way, and I'll walk you step by step through the calculus proof. This video is part of a playlist on monopoly theory, and I'd encourage you to watch the other videos as well. The marginal cost curves look something like this, with a downward sloping demand curve. Remember, the monopoly's demand curve is the market, the marginal revenue curve. Also, I'll draw in the marginal cost curve and the average total cost curve. The monopolist produces where marginal cost is equal to marginal revenue at a quantity, I call it QM, the quantity produced for the monopoly. And they produce at a price of, if I go straight up right there and over, PM, or price the monopoly would charge. The total revenue curve looks something like this. It's a curving up and then down, and total cost curve looks like this. And the monopolist will produce where the slope of the total revenue curve is equal to the slope of the total cost curve. In fact, I'm gonna draw this a little bigger for you too, and that's the profit curve. Let me draw this larger so you can see it. Let me put the quantity in, and on the y-axis I'll put total revenue now, and that's the total revenue curve. Also on the same, I'll plot the total cost curve. Looks like that. Total cost. And finally, I will put in the profit curve. And profit looks like this. There. And label that profit. The slope of the total revenue curve is equal to the slope of the total cost curve where profit is maximized. The slopes are equal. And we know that is marginal revenue and marginal cost. And at this point, profit is maximized right there. Now I'll focus just on the profit curve as I step through, and I'm getting ready to do the calculus proof, so just hang in there with me. I'm going to set it up for you. So here's the profit curve, and the monopolist maximizes profit at that point where slope is equal to 0, right there. And the change in profit divided by the change in quantity. So what happens to profit as quantity changes or increases in this case? We have that delta is a change in, by the way. So we have D means delta. So d pi, so I'm using pi as the symbol for profit. That's common to do in economics. Divided by the change in quantity, or dq. d pi dq. And this means what happens to profit as quantity changes, and that's what I'm going to prove using calculus. So how do these things change? Obviously profit's not constant as quantity changes, and the rate of change can be measured by the slope of the profit curve, and that's where it's maximized when slope is equal to 0. So when I take the first derivative, which I'm going to do, I'm going to take the first derivative, set it equal to 0 and solve it. That's where profit is maximized. So here we go. Ready? Let's go. It turns out that profit is equal to total revenue minus total cost. Profit is equal to price times quantity, which is revenue, minus total cost, which is a function of quantity. The total cost curve looks something like this. What happens to total cost as quantity increases? How does it vary? Also, it's not constant either. So I'm going to say total cost is a function of quantity. So profit is equal to price times quantity, and I'll just use P and Q now. So profit is equal to price times quantity, P times Q, minus total cost, which is a function of quantity. So profit is equal to price times quantity minus, and I'm going to show you that total cost is a function of two things. Total cost is total variable cost and total fixed cost. So total cost is equal to total variable cost plus total fixed cost. And you'll see in a moment why I'm doing this, so just hang in there. So now I have, put the labels back, I'll get rid of the total cost curve. The change in profits due to a change in quantity is equal to price times quantity divided by a change in quantity minus a change in total variable cost divided by a change in quantity minus a change in total fixed cost and a change in quantity. There's a reason I'm making that gray, by the way. So let me plot this out. I'm going to plot total fixed cost, and notice it's a horizontal line. The slope is 0, and it doesn't change with quantity. Again, slope is equal to 0, so I can just say that does not change, so I can ignore that and get rid of that part of the equation. Now I'm going to write this in proper calculus notation, and I'm using D's instead of the change in, and I'll use that calculus notation all the way through. So it's going to turn out that this part of the equation, that's going to be marginal cost. And so let me plot it out for you again. So if I have change in total variable cost and look at the slope of the line, which is my first derivative, this is going to equal to that part of the equation, and that is marginal cost. In other words, how does total variable cost change when quantity changes? Now I'm going to look at the other part of the equation, and that part right there. And I'm going to have to use the product rule to take the derivative of that, and I'll tell you what that is in a moment, the product rule. Remember, P times Q is revenue, so I could graph this out as well, and I'll show you the graph what that looks like. So I have quantity again, and total revenue on the y-axis. The total revenue curve looks like that. And how does revenue change when quantity changes? Again, revenue is price times quantity. Clearly, total revenue changes as quantity changes. The slope of the total revenue curve is a tangent line, and it turns out the slope is the first derivative of that equation, and it's marginal revenue. Now the product rule is defined as, I guess I don't need this after all. Let me get rid of this stuff on the left again. There. So the product rule is if I want to take a derivative of two items like P times Q or two functions, the way I do that is I take the first function, in this case it's P, times the derivative of Q, plus the derivative of P times Q. So I have P, which is price, times the change in quantity divided by the change in quantity, and I'll talk about that in a second, plus the change in price due to a change in quantity, which is the first derivative of the P, times Q. So let me write this over again. And this is equal to P. Let's pull the P down. The change in Q due to a change in Q is just 1, so I won't write that 1 out. So it's P plus, and this is typically written with a Q first, and then the change in price to do a change in quantity. And that is the first derivative of that part of the equation. Now let me pull that down, and then pull this other part down. And this is, how does profit change when quantity changes? So let me move that up and start over. So I'm almost done, so hang in there. This part of the equation is marginal revenue minus this part of the equation, which is marginal cost. And if you recall, profit is maximized when the slope is equal to 0. So I'm going to set this equation equal to 0. I'm going to do a little algebra. I add marginal cost to both sides of the equation. So I have marginal revenue is equal to marginal cost. What about that? And that's where profit is maximized. So there you have it, the calculus proof for monopoly theory. Hope you grasp it. Again, I drew some graphs, did the calculus. I would really encourage you to watch all the videos in the playlist on monopoly theory.
In today's video lesson, we're going to distinguish between a regular monopolistic market and what is known as a natural monopoly. Before watching this video, you should watch the 2 previous lessons in which we have explained how demand and marginal revenue for a monopolist's output are determined, and how a monopolist will determine its profit maximizing level of output compared to its revenue maximizing level and the other areas of economic profit and or loss that a monopolist may experience. So you should recognize on the left here the graph for a regular monopolist facing a downward sloping demand curve with a average total cost curve and a marginal cost curve. The monopolist wishing to maximize profits will follow the profit maximization rule and produce where its marginal revenue equals its marginal cost. And such a firm, as we see here on the left, will then be able to charge a price higher than its average total cost, and therefore earn economic profits. Notice that this monopolist has a fairly normal looking average total cost and marginal cost curve. Marginal cost slopes downwards and then it slopes upwards when the firm begins experiencing diminishing marginal returns. Average total cost slopes downwards and then slopes upwards once marginal cost is greater than average total cost, for all the reasons explained in previous video lessons. In today's activity, however, we're going to look at a special type of monopoly, one in which average total cost diminishes or declines over a much broader range of output than a regular monopoly. We're going to revisit the concept of economies of scale and show the instance in which a monopolist experiences economies of scale over a much wider range of output than the typical firm that we see on our left here. So looking at our graph on the right, we're going to now illustrate the case of a natural monopoly, and then we'll define what a natural monopoly is. So as I have already indicated, if average total cost decreases over a much wider range of output than is typical for a firm, in other words, if the ATC is stretched out and doesn't reach its lowest point until some level of output way beyond where demand intersects ATC, then this may be a natural monopoly. So as we can see, this is really no different than our graph on the left, except I have taken this range of the ATC, the range over which economies of scale are experienced, and I've stretched it out over a much broader or wider range of output. So this firm is experiencing economies of scale, in other words, a decrease in its average total cost resulting from an increase in output over a much wider range of output than the firm on the left. In order for the firm on the right to achieve its minimum average total cost, it must produce a much greater quantity than the firm on the left. So beyond a certain point, the firm's average total cost will start increasing again. And we can infer that there is a marginal cost curve that is also stretched out over a much wider range of output. And because of the mathematical necessity, marginal cost must intersect ATC at its lowest point. So what do we have here on the right? We have an industry in which economies of scale are experienced over a very wide range of output. What does this really mean? And what is an example of such an industry? Let's imagine an industry such as water provision in a city. To provide water to the households and the businesses in a city of, say, 1 million people, a firm must invest in great amounts of infrastructure, including ways to get the water from a freshwater source to the city, and then ways to distribute that water to the different buildings all over that city. If a firm was very small and trying to provide water to only a handful of households, that firm would face very high average total costs. You can imagine if there were, say, 20 firms competing with one another to provide water to a city in which the socially optimal level of output is relatively high. Let's look here. Let's say that the socially optimal level of output of QSO, where marginal cost equals demand, which represents marginal benefit. If this market providing QSO were divided up among, let's say 1, 2, 3, 4, 5, 6, 7, 8 different firms, each firm providing only a fraction of the total output, each firm providing water would have very high average total costs. Why is this the case? Why is it that if 8 different firms were trying to provide water for a city of 1 million people, each firm would have very high average total costs? The reason is that no individual firm would be able to achieve the economies of scale necessary to bring the average total cost down closer to the price at which marginal benefit equals marginal cost. So in this case, the QF represents the quantity of one firm of 8 in a competitive water market. Notice that if this market was filled with 8 different firms, each firm would have very high average total costs. This is an industry that would actually be better off with only one firm producing water for the entire city. The infrastructure needed has such high fixed costs associated with it that only when a firm produces the entire quantity of water for the industry can ATC approach anything close to the price needed to achieve a socially optimal level of output. So as we can see, if one firm were to provide the water, then that monopolist's average total costs would be much lower than if the market were more competitive. Each firm would have higher average total costs. So generally speaking, to determine whether a particular industry is a natural monopoly, we must look at the demand curve and the average total cost curve. So here's the rule of thumb for a natural monopoly. If demand intersects ATC while it is still downward sloping, then the industry is a natural monopoly. Basically, in such an industry, there is simply not enough demand for the good to necessitate more than one firm producing that good. The industry is actually better off, and society is therefore better off if only one firm produces the good. But there's a problem. In such a case in which a natural monopoly exists, if the monopolist is allowed to charge a price that corresponds with its profit maximizing, where MC equals MR, its profit maximizing level of output, we'll call that QPM, then the price the firm charges will be much higher than the socially optimal price. So but the monopolist price of PM is much greater than the price that corresponds with the socially optimal level of output. Down here where MC equals MB, this is PSO. Now we are presented with a dilemma. A natural monopoly exists in this market, but if that firm, if that one monopolist is allowed to charge the price that it wishes to charge in order to maximize its profits, it will restrict its output to QPM and charge a price that is much higher than what is socially optimal. What this means is that in such industries as water utilities or others like natural gas utilities or electricity, there will be an underallocation of resources towards these necessary goods, and monopolists will charge a higher price, basically extracting welfare from consumers and transferring it to the monopolist itself. How can society achieve a socially optimal level of output in a natural monopoly? The solution lies in government intervention. As we have explained, a monopolist tends to restrict output and raise its price in order to extract consumer surplus and turn it into profit for the firm. But as we can see here, a natural monopolist isn't likely to earn a great level of economic profit, even if it is profit maximizing, because its average total costs are so high due to the economies of scale that exist in such a market. So we can see that the yellow area represents the firm's economic profit. So even though consumers are paying a much higher price than they would be if we had a socially optimal level of output, The monopolist is not extracting a great amount of profit from society due to the very high average total costs arising from the economies of scale. This is a market that requires government intervention. A combination of price controls and subsidies can help achieve a more socially optimal level of output in the case of a natural monopoly. How could subsidies help achieve something closer to QSO, where marginal benefit equals marginal cost? Well, as we can see, subsidies are actually necessary in order to get a monopolist in such an industry to produce QSO. The reason a subsidy is necessary is that if a government were to impose nothing but price controls, let's assume the government set a price ceiling on water of the socially optimal price. We're going to put a horizontal line right here. Suppose that the government has set a price ceiling at the PSO, the socially optimal price. Now, a price ceiling essentially means that the monopolist can only charge PC, or price ceiling, meaning that the monopolist's marginal revenue now equals PC. The profit maximizing monopolist will increase its output to QSO, since this is the new MC equals MR level of output. However, this firm will clearly be earning economic losses at QSO at a price of PC, or PSO, the socially optimal price. This monopolist in the long run would shut down because its economic losses, represented by the blue rectangle, would create a strong incentive for this firm to leave the market in the long run. No profit maximizing monopolist would want to remain in the market providing water or electricity or natural gas in a situation in which it is earning economic losses. So a price control alone at the socially optimal price will not incentivize production in the long run of such goods. What is needed instead is a subsidy, a per unit subsidy, a payment from the government to the monopolist aimed at reducing the monopolist's marginal costs. To illustrate the effect of a subsidy, we're going to draw a new graph here in which we can show how a subsidy might actually help achieve the socially optimal level of output. Here we have an extended version of the graph we drew above. We can now see that the marginal revenue becomes negative at a certain point for this monopolist. In other words, the firm would never voluntarily produce beyond this point right here. This is where the firm's revenue is maximized. We'll call that QRM for the revenue maximizing level of output. But how could a government incentivize a firm to produce at the socially optimal level of QSO? This, of course, is where marginal benefit equals marginal cost. In order to get a monopolist to voluntarily produce out here at QSO, a subsidy is needed. Now, the profit maximization rule says that a firm will always produce where MC equals MR. In order to get a natural monopolist to produce at QSO, the government must therefore impose a subsidy that reduces the marginal cost so that it intersects MR at this point right here. So this is illustrated as a downward shift of marginal cost into the negative range of the price and cost axis. How can a subsidy reduce marginal cost until it is negative? Well, that's basically what we're trying to show here. A negative cost, in effect, is a revenue for the firm. So in order for the firm to produce at QSO, the government will actually be paying for the firm's production of this utility, of this water or electricity or natural gas. So the payment from the government to the producers appears on a graph as revenue for the firm. The monopolist will now have an incentive to produce a socially optimal quantity so that a price control set at PSO, a price ceiling, is now realistically met by the firm. And in fact, a subsidy that lowers marginal cost will also lower ATC. So it's possible that a utility company receiving a subsidy from the government can actually earn economic profits by producing a socially optimal level. So it looks strange on the graph because marginal costs become negative and average total cost becomes negative. But since costs are the opposite of revenues, a negative cost is like a revenue for the firm. This is a case where a monopolist is being paid to produce the utility. So I'm looking out the window of my classroom here in Zurich, Switzerland, and I can see a building called EKZ. This building is owned by the Zurich utility company that provides electricity to my school, to my house, and to everybody who lives in the city of Zurich. EKZ is a public-private cooperation. It is a company that is privately run but publicly subsidized and regulated. Why is a company like EKZ or any monopolist providing utilities to a city regulated by the government? The reason is that without regulation, a natural monopoly will charge a price much higher and produce a quantity much lower than what is socially optimal. Therefore, we commonly call natural monopolies regulated monopolies. Regulation refers to the government's use of price controls and subsidies to encourage a natural monopoly providing a utility to produce something closer to the socially optimal level of electricity, water, natural gas, sewage treatment, garbage collection, and so on. These are industries that generally, due to the large economies of scale, will be natural monopolies, illustrated by a graph in which demand intersects average total cost while it is still downward sloping. This lesson is going to look more closely at a purely monopolistic firm producing output in a monopolistic market. As we saw in a previous lesson in which we introduced the monopolistic model, the demand as seen by a pure monopolist represents the total market demand for the good being produced. This makes sense because the firm is the only producer. There is no need to draw two separate diagrams as we did in perfect competition, one for the market for the output and one for the individual firm. The individual firm's demand is the market demand. Also in our previous lesson, we illustrated and explained why marginal revenue for a monopolist always lies below the demand curve for the monopolist. This means that at any given level of output, the firm's marginal revenue will be less than the price that it sells its output for. In today's lesson, we're going to explore three different concepts relating to pure monopoly. First, we're going to revisit the profit maximization rule that we learned in our unit on perfect competition and determine whether the same rule for maximizing profits applies to a monopolist. We'll compare the profit maximizing level of output produced by a monopolistic firm to the revenue maximizing level of output. And we'll determine where a monopolist should produce in order to maximize its total revenues instead of its profits. Finally, we will be looking at the price elasticity of demand for a monopolist's output, and we'll see how we can determine over which range of output demand is relatively elastic and over which range of output demand is relatively inelastic for a monopolist's product. Let's begin with the profit maximization rule. When studying perfect competition, we learned that in order to maximize its profits, a firm should always produce at the level of output where the marginal revenue to the firm equals the firm's marginal cost of production. At this level of output, there is no way a firm can increase its total profits by either reducing its output or by increasing its output. Let's look at our graph and determine what the profit maximizing level of output for this monopolist is. First, we have our marginal revenue curve. We can see that marginal revenue slopes downwards and marginal cost slopes upwards, but there's clearly a point at which marginal revenue equals marginal cost. This point right here is our profit maximization point. A monopolist hoping to maximize his total profits should determine the level of output at which marginal revenue equals marginal cost. And that quantity right there, we'll call that QPM for the profit maximizing quantity. So the question is, how do we illustrate the area of economic profits earned by a monopolist at this quantity? Now, a mistake that students commonly make, and I'm going to show you this mistake so that you don't make it yourself in the future, is to draw a dotted line over from this point and indicate that this is the price the firm will charge at its profit maximizing level of output. This is a mistake, however, because in fact, that dotted line indicates the firm's marginal cost and its marginal revenue at the quantity of QPM. To find the price, we must go all the way up to the demand curve, because as you recall, demand represents the willingness and ability of consumers to pay for a good. Therefore, demand represents the price that consumers are willing to pay. So in fact, the price the monopolist will charge when producing at its profit maximizing quantity is determined by the level of demand for that quantity. If a monopolist charged a price lower than that, down here, equal to its marginal revenue, let's say, clearly there would be a disequilibrium in the market because the quantity demanded at a price of MR is much greater than the quantity that the monopolist is actually producing. There would be a shortage in the market at a price of MR. Therefore, a monopolist will not charge that price. Instead, it will charge the price that consumers are willing to pay for this particular quantity, which on our graph is QPM. Let's illustrate the area representing the firm's economic profits at a quantity of QPM. In order to find and calculate economic profits, we must know the average total cost, because total profits equal price minus average total cost times the quantity being produced. All we need now is our average total cost because we have the price and we have the quantity that the firm will produce. In order to find average total cost, we'd go up from the quantity to our ATC curve, draw a dotted line over, and right there on our vertical axis is the firm's average total cost of producing QPM units. The area of economic profit, therefore, is simply the price minus the average total cost times the quantity. And on our graph, it is a rectangle. The blue rectangle on our graph represents the maximum level of economic profits that this monopolist can hope to achieve given the level of demand that it faces and given its costs of production. Any level of output greater or less than QPM will result in a reduction in the size of its profit rectangle. Therefore, by producing at QPM, the firm maximizes its total profits. We can see that a purely monopolistic seller has a better chance of earning economic profits in the long run due to the fact that these profits cannot attract new firms. In pure competition, profits attract new firms. The entry of those firms reduces the price and eliminates the profits. But due to barriers to entry, a monopolist can hope to maintain its economic profits in the long run. Entry into a monopolistic market is blocked. Economies of scale, legal barriers, ownership of essential resources, any of these things might be reasons that new firms find it difficult to get into a monopolistic market. Therefore, monopolists can earn economic profits in the long run, as long as demand for its product remains strong and its costs remain relatively small. Let's move on to the second topic today. Next, we're going to talk about the level of output that a firm would wish to produce at in order to maximize its revenues. Now, we don't typically think of firms as revenue maximizers. We think of firms as profit maximizers. But what if a firm decided that its objective was not to earn the greatest level of profits possible, but to earn the highest revenues possible, even if that meant its total profits would be less than it would be at the MC equals MR point? If a firm had the desire to maximize its revenues, then it should produce at the quantity where marginal revenue equals 0. Now we're going to look at a graph and explain why this quantity is where total revenue is maximized. First, let's identify this quantity on our graph. Look at the marginal revenue curve. We can see that at low levels of output, marginal revenue is relatively high. But as the firm increases its output, the firm's marginal revenue decreases due to the fact that it is having to lower the prices of its output in order to sell additional units. Marginal revenue continues to decline until it equals 0, which in our graph is right here. When the firm's marginal revenue equals 0, its total revenue is maximized. So I'm going to put a quantity here that says QRM for revenue maximization. So what price should a monopolist charge at a quantity of QRM? Well, just like we determine the price at QPM, we can draw our dotted line up to the demand curve and over to the price axis to show the price that the firm can charge at the quantity of QPM. At QRM, the revenue maximizing quantity, the firm can charge a price of PRM. As you can see, the price the firm will charge when maximizing revenues is lower than the price it will charge when maximizing profits. But this is because the firm is producing at a greater quantity now. The quantity QRM is greater than the quantity QPM. So why is this the revenue maximizing quantity? And what impact does producing at the revenue maximizing quantity have on the firm's profits? Let's answer that first question first. Why is QRM the revenue maximizing quantity? Well, we need to remember what marginal revenue represents. Marginal revenue is the change in total revenue resulting from a particular change in output. In other words, as the firm's output increases from 0 units here at the origin to QRM, its marginal revenue is positive. If marginal revenue is greater than 0, then total revenue is increasing because marginal revenue is the change in total revenue. However, if marginal revenue is less than 0, then total revenue is decreasing. In other words, if the firm continued to produce beyond QRM, its marginal revenue would begin to diminish, would become negative in fact. Beyond QRM, total revenue is falling. A firm would in fact never wish to produce beyond the quantity of QRM. The firm's total revenues would be declining, but in order to increase its output beyond QRM, its total costs would be increasing. This means that, of course, economic profits are decreasing. Even a revenue maximizing firm would not want to produce beyond QRM. Of course, total revenue is maximized at QRM. Therefore, any level of output beyond that, total revenue will decline. So now let's examine the impact on the firm's economic profits by increasing its output from QPM to QRM. In our particular firm, we can see that in fact at QRM the firm is still earning some economic profits, simply because the price it can charge at that quantity is still slightly higher than the firm's average total cost. I went up to the ATC curve, drew my dotted line over, and I can see that the firm's average total cost is still slightly lower than the price. But clearly the firm's economic profits at this quantity are less than they were at the quantity of QPM. The firm sacrificed some profits, but it did earn greater revenues. The reason its profits are smaller, however, is that the firm's total cost increased by more than its revenues increased between QPM and QRM. A firm wishing to maximize its profits should reduce its output back to the profit maximizing quantity of QPM. Now, the final thing we're going to discuss today is price elasticity of demand for a monopolist's output. Looking at a firm's demand curve, is there any way to determine over which range of output demand is relatively elastic and over which range of output demand is relatively inelastic? The answer is yes. Here's how we can determine whether demand is elastic or inelastic. If the marginal revenue is greater than 1, then PED is greater than 1. In other words, demand is elastic. We'll explain why this is true in just a moment. Secondly, if marginal revenue is less than 1, then PED is less than 1. In other words, demand is inelastic. Why is this the case? Earlier in the course, we explained what is known as the total revenue test of elasticity. The total revenue test, we're going to move up here now, essentially says that if a decrease in price leads to an increase in total revenue, then demand is elastic. PED is greater than 1. This means that consumers are relatively responsive to the lower price. A particular percentage decrease in price must have led to a greater percentage increase in the quantity demanded. Hence, demand is elastic. That's what's happening in a monopolistic market as long as the marginal revenue is positive. If a firm lowers its price between 0 and QRM, demand is elastic because consumers are relatively responsive to the lower prices. As the price falls, consumers increase the quantity that they consume by a percentage greater than the decrease in price. Otherwise, total revenues would not be rising for the firm. The total revenue test also taught us that if a decrease in price leads to a decrease in total revenue, then PED is less than 1. In other words, a particular percentage decrease in price led to a smaller percentage increase in the quantity demanded. The firm's total revenue will fall if this condition holds true. Therefore, price elasticity of demand is less than 1. Consumers are no longer very responsive to decreases in the price. So beyond the quantity at which MR equals 0, PED is less than 1. Demand is inelastic. On our graph, we can draw a dotted line up to the intersection. We can draw a dotted line up from the intersection of MR and the horizontal axis to our demand curve, and we can see that along the demand curve, there is a range over which PED is greater than 1, and beyond the QRM level of output, there is a range of the demand curve over which PED is less than 1. This implies, of course, that there is a quantity at which demand is unit elastic, and that quantity is right where marginal revenue equals 0. So right here, above the QRM level of output, PED equals 1. A particular percentage decrease in the price will lead to an identical percentage increase in the quantity demanded. Therefore, there will be no change in the firm's total revenue as it changes its level of output and its price right around the QRM level. Total revenue is maximized at QRM. So this lesson went through 3 different characteristics of a purely monopolistic market. We looked at the profit maximization rule, which says that a firm should produce where marginal revenue equals marginal cost in order to maximize its total profits. This rule is true for any market structure, whether it's perfect competition or pure monopoly or something in between. We then talked about the revenue maximization rule. If a firm wishes to maximize its total revenues, it should produce where marginal revenue equals 0. Because if the firm's marginal revenue is greater than 0, then decreasing its price and increasing its output will add to total revenues. When marginal revenue becomes negative, then a decrease in price and an increase in output will decrease the firm's total revenues. Therefore, total revenues are maximized when marginal revenue equals 0. Finally, we explained how the total revenue test teaches us if marginal revenue is greater than 0, then demand is elastic, since a particular decrease in price will lead to a greater percentage increase in the quantity demanded, causing the firm's revenues to rise. If, however, marginal revenue is less than 0, then the price elasticity of demand is less than 1, since a particular percentage decrease in price will lead to a smaller percentage increase in quantity demanded, causing the firm's total revenues to decrease. In our next lesson, we're going to look at purely monopolistic markets and firms and determine the extent to which such firms are productively and allocatively efficient compared to similar perfectly competitive